Didn't work.
Didn't work.
Oh well, that's okay.
There it is.
Woo! All right. All right, hello. My name is Sean Griffin. I am a committer on Rails. I maintain an active record. I'm sorry, please direct any hate mail to me. And I'm also the co-host of the Bike Shed podcast, which if you haven't listened to, you should, because it's awesome. This is my cat, Sinatra. This is my dog, Django. And I would like to talk to you about Rails. So we're going to talk about API design, and I'd like to take a look at a new API that we are introducing in Rails 5 as an example of how to go about this process. It's called the Attributes API. It allows you to hook into the typecasting system in Active Record, and we're going to talk about the process that went into developing it. So there's roughly 6 steps. It's not necessarily a process that can really be like, here's exactly how you go about it. But the first step is, of course, to identify what problem you need to solve. Roughly, and the keyword here being roughly, figure out what you want it to look like. You don't want to overspecify too early, but you do want to have an idea of what you're shooting for. You need to have good test coverage, because you'll presumably be doing a lot of refactoring. And then for API design for gems, I like to go with what's called an inside-out development process, where you start with the objects in your system and focus a lot on the implementation, and then develop the additional sugar around it as needed. Use those objects internally, compose those together, and then where you see there's pain in composing them, that's where you extract your DSLs. So the first step is, of course, figuring out what you actually need to build. And in any large legacy code base, and don't get me wrong here, Rails is just a large legacy code base, you can find plenty of concepts that exist, but don't yet have a name. And so one of the greatest things you can do to find these APIs for other developers in your company or for users of your gem to use is try and find these concepts that need a name. A lot of the common signs of where this could be beneficial include code that is structurally similar or duplicated a lot throughout your code base, methods that have the same prefix, or multiple modules or classes which inherit from each other and frequently override the same method. So one of these concepts that became apparent inside of Active Record as I was working on it was changing the type of an attribute. So for a rather simplified example, let's say that you have a price column, and rather than representing that as an integer or a float, you want to use a money object. So in Rails 4, you might do something like this. So we're overriding the method price and price equals, the setter and getter. And in the getter, we are wrapping the value in a money object. And then in the setter, if we received a money object, grabbing the amount out of that, otherwise just calling super. And when you write code like this is fine, but it's actually kind of reasonable to wonder, what Rails magic am I going to break here? Or am I going to break any Rails magic? A lot of people wonder, can I even override an attribute that exists in the database? And the answer is it depends. But here's a list of some things that might work unexpectedly if you wrote this code. So it's very possible that you'll break before typecast or dirty checking. Because you haven't hooked into what it looked like before typecasting, an object might be detected as changed even though it hasn't. And then form builder integration, you have no control over necessarily specifically when data comes in from the form or how to present something to the form. And there's a lot of things that you can't do this way that you might want. You might want control over the arbitrary SQL representation, or more importantly, you might want to be able to pass it to where. There's a contract that we have, which I'll look at that towards the end here, but where any value that you get from a getter on Active Record, if you pass that same value to where, you want to get the same record back. And right now you have no way to add the ability for additional types or new objects to be passed to where. And this is really important for gems like the money Rails gem. But we do override attribute types all over the place in a lot of ways. And you might be wondering how we do it internally in Rails. And if your guess was a giant pile of hacks, you'd be right. It's a giant pile of hacks. So we're going to look at some Rails internals. That text was supposed to be white. This is not for the faint of heart, so sorry. So I know this method's going to be really, really hard to read. It's OK. This one you shouldn't try and read. Don't worry too much about the specifics. But roughly what this is doing is, so this is from time zone conversion. It's from a feature called time zone aware attributes. It is a thing that is on in all of your apps, and none of you know what it does. And if you do know what it does, sorry for lying. Basically, it deals with converting times from whatever the current time.zone is to UTC before it goes into the database, and then also coming back out, because we always store things in UTC. So the first thing it's going to do is grab the value and convert it to the time zone. Then it's checking to see if the attribute was changed previously and deciding how to grab the previous value based on that. It writes the attribute after the time zone conversion. If the attribute had changed before, calls will change bang, which is the way that you mark something as dirty, even if dirty checking wouldn't have picked it up. And then also does some stuff to hook into the caching of typecasting. And all of this is done in a bunch of string interpolation so that we're not looking things up with hash lookups at runtime. So this has to jump through a lot of hoops, specifically to maintain the before typecast version and not break dirty checking here, because created at and updated at need to get set. So these are some of the big red flags to me. We're overriding an attribute reader and writer. We are duplicating code from other parts of active record. The line where we're checking if something has changed and grabbing the previous value, that exact line appears in a lot of places. And this is a lot of hoops for what is ultimately a relatively small change to the behavior of that object. And there's a lot of subtle bugs with that. And in Rails 4.1, most of them are fixed in Rails 4.2, where a lot of this work happened. And in Rails 4.1, though, that caused major issues, especially related to time columns and array columns. And it's difficult to find these bugs because this is touching a bunch of concepts scattered in a bunch of different places. So another case where we change the type of a column in active record is if you use the class macro serialize, which in older versions of Rails was how you would go about saving an array or a hash if you were on a database that didn't have support for array columns, HStore, JSON, JSONB, et cetera, et cetera. We don't recommend using it anymore, but it's still there, and we're not getting rid of it anytime soon. So this is one of the places where it overrides what is essentially read attribute but isn't quite read attribute. It's checking to see if the name the attribute that you're accessing is in the list of attributes that have been serialized, and if so, reaches into this other internal object, which is what we stored in, which is how we represented it internally that we never expose, and grabbing the value off of that. And I really, really wish that serialize was implemented just by overriding the reader and writer, like most of these cases are. But it's not quite that simple. So here's some more code from that module, and some more, and some more. And you get the picture. And there are several more pages of this that I left out for brevity. I mean, that's already like, I think 10 methods I just showed. Literally if you just look for every method in Rails 4.1 that exists privately or publicly that contains the word attribute, the serialize macro probably overrode it. So same thing, we're overriding an attribute reader and writer. Ironically, the one method that this doesn't actually specifically override is read attribute, but it's overriding every method that call, so same thing. It's duplicating a lot of code. So many of those methods are if the attribute is serialized, almost the exact line from the original definition of whatever it's overriding with one minor modification. It's jumping through a ton of hoops. It overrides everything, and well, there were a lot of bugs here as well. One of the biggest long-standing ones was with serialized, you were commonly working with an array and a hash, and in Ruby, it's considered pretty idiomatic to mutate those. And as opposed to a string, where usually if you're going to concatenate to a string with active record, you're more likely to use plus equals than the shovel operator. And so we can detect mutation there because you're going through assignment. But if you're assigning a hash key, which is a thing that's more likely to happen here, we weren't able to detect that mutation. So serialized attributes, the solution that we came up with way back in the day was just, hey, let's always treat it as changed. That could never cause problems. And this one thing I didn't show here is that this class macro ends up modifying the columns hash, which is something that we'll talk a little bit about later. And this is enum, one of the newer features that we introduced in Rails 4.1. And same deal. This code's a little bit small, but that first blob there is overriding the writer, the second blob is overriding the reader, and the third blob is overriding the before typecast version of the reader, because once again, in all of these cases where we're overriding the reader and the writer, we're having to jump through hoops to not break dirty checking. And there's a bunch of other parts of this I didn't show, which are just various points in the life cycle that are being overridden. So we're overriding a reader and a writer, we're duplicating code from other parts of active record, we're jumping through a lot of hoops yet again, and yes, there were lots of subtle bugs with this. And one of the big missing features in Rails 4 that people have asked for over and over again with enum is if you've got, say, status and it's enumerated to published or draft, you couldn't actually do where status draft. You would have to call the draft scope, which would do the same thing, but you would actually have to pass the numeric value to where because there was no way for this to hook into where, and trying to do it previously, even if we manually were overriding where in Rails 4, would have been extremely difficult to do without breaking anything. So at this point, we've definitely found a missing concept. Typed attributes appear all over the model layer of active record, and if we want to do this so much, maybe our users want to do it as well, or at the very least, plugin authors. So we've talked a lot about typecasting, but I also want to have an aside here and define exactly what typecasting is. And it's pretty straightforward. It is the process of explicitly converting a value from one type to another. So here's an example. If you have the string 1, its class is string. If you call toI on it, its class changes to fixed num, and that's typecasting in a nutshell. Now, what we're doing in active record is called type coercion, which is basically the same thing, but when it happens implicitly instead of explicitly. So if you have, for example, a user model and it has an age column, and that's presumably of type integer, you assign a string to it. When you read it back out, you're going to get a fixed num because we implicitly coerce this to the correct type. Now, a perfectly valid question is, why do we even do this in the first place? And this ultimately is a side effect of a design decision that was made way back at the very beginning of Rails. Ultimately, it was decided that when you take input from the form builder, you're going to want to pass that hash directly to attributes equals, which means that active record now needs to perform type coercion and know about what input the form builder is going to give and how to properly coerce for any arbitrary SQL type on the back end. One other more subtle implication of that is that we can't do the semantically correct thing if you give us junk input, which would be to raise an exception of some kind. If we just legitimately if you have a JSON column and you just pass us a string of utter nonsense, the right thing to do there, in my opinion, would be to raise some sort of JSON serialization exception. But we can't do that because a user passing a weird value to the form shouldn't cause your server to 500. So instead, we have to treat junk input as nil, which causes all kinds of other issues, but is ultimately better than the alternative. And so in Rails 4 and earlier, the only way to have a coerced attribute is to have it be backed by a database column of a specific known type. And if we want to be able to hook into that behavior and maybe use it, modify independent of the database, well, that's what this new API is for. And this is the earliest stages of it, what we wanted it to look like in generally the most simple case. So this would be most likely redundant with the schema definition, but if you were to be explicit about some of the columns in the model, this is what it might look like. You have a product, it has a name attribute, which is of type string, and you have a price attribute, which is of type integer. And so this is the rough idea of what the API, what we want the API to look like. Specifically, we can infer at this point that we're going to need the name of the attribute and some way to represent the type, but how we're going to represent either of those, maybe we'll change those. I don't know if I don't want to just read a random quote, so I'll just leave that up there for a moment. So we start to think about each of our smaller pieces that is going to make this up. We're probably going to have an object responsible for the state transitions between the various representations of a type. We're probably going to have an object that represents an attribute in one of those states. We might even have an object representing a collection of those. But really all we know at this point for sure is that we're definitely going to need to have some sort of object to represent a type. And that's probably not going to be enough for reasonable implementation of this API. But we're going to start this process by composing those objects manually and then looking for the places that we can extract collaborators and make composing these objects together easier. And before we start introducing the API, I need to say a few brief words about refactoring. The first rule of refactoring is have good test coverage. The second rule of refactoring is to have good test coverage. And the third rule of refactoring, see rules 1 and 2. So this is how we're going to start. I'm going to be showing a lot of diffs here. One thing to note, I couldn't figure out how to get the color scheme to change for code. So removed lines are going to be green and added lines are going to be blue. So sorry, but yeah. So just keep that in mind that the large blobs of green aren't a bunch of code we added. It's a bunch of code we removed. So this is the quote-unquote type system in Rails 4.2, or in Rails 4.1 rather. Like many things in Rails, it is a giant case statement where the left-hand side is a symbol. You'll see this all over the place, especially within Active Record. And they're not fun to tear apart. There's also one piece here that stood out to me especially, which is the comment on this. I especially loved the basmati rice picture from yesterday, because this was definitely one of those for me. Casts a value, which is a string, to an appropriate instance. And which is a string is kind of a lie, because this method gets called anytime you pass any value to any setter anywhere in Active Record. And like, I mean, it's pretty straightforward to think about ways in which you might assign not a string. I mean, like, really? And I don't like to bash on other people's code too much, but it's okay. I get blamed it was this guy, so. Kylie showed me the truth behind all of this tomorrow, and it makes so much more, or yesterday, and it makes so much more sense now, because when he wrote this, he was probably dressed like this. All right, enough bashing DHH. So the first thing that we want to do is introduce the type object to our system. Right now, the typecasting lives on column, so that was the place to start. And the first commit going towards this was just to introduce the new constructor argument. We wanted to have it be injected so that we would be able to easily override it. All we know is that we're going to have this type object. We don't know anything about it. And in fact, at this point, every caller of this was passing in nil. And then we started to introduce a object that just had a method and responded to whatever we wanted with nil. And from there, then started to figure out, OK, we've got string, integer, float, et cetera, et cetera, et cetera. So we want to start removing each of these case statements. There were several methods in column which had the same case statement over and over again. And we wanted to move all of those to the type objects. So this is the first one, and it was originally called in the constructor, it was called the simplified type, which took the SQL type string and figured out what symbol to call it, things like string or integer. And this was the entire implementation, excluding adapter-specific stuff. We also removed the line where we assigned that in the constructor and instead replaced it with delegating the type to cast type. Now, that regex ultimately ended up getting pushed into the connection adapter, so it could figure out which type class, which is not the same thing as a Haskell type class, which type object class in Ruby we were going to inject into the column itself. But then the actual implementation of this method on each of these columns was just def type symbol integer, no logic whatsoever. And so we go through and replace some more case statements over time. This was the typecast method. We got rid of that huge case statement and instead replaced it with this. The first branch there is to deal with serialized types, and that ultimately went away. And again, we delegate more and more. Here we're also delegating several predicates about the type. move those methods, move those methods, and so on, and so on. And this is an example of what a type object might look like. They tend to be pretty simple. The types themselves have no state. They only exist for transitions. So going from database values to Ruby values, from Ruby values to database values, from form input to Ruby values. And the methods end up being called typecast, serialize, and deserialize. Actually, I think typecast changed to cast. And string happens to be one of the simplest types. This is actually what it looked like in 4.2. This is more complex than what it looked like in that case statement in 4.1, and that's because the version in 4.1 had several bugs that became painfully obvious once we had one specific place to deal with everything related to string types. So now that we've got a lot of the framework for this in place, let's write a test for using the actual API. So we're going to create a table. We're going to say that this thing which on the database is a float, but we want to work with it in Ruby as an integer. It's contrived. It's not realistic, but it shows the proof of what this is meant to accomplish. And so we assign a string of 1.1, and the one that we did not overload, which is still a float in the database, should be cast to a float. The one that we did overload to say that it's an integer, it should be an integer. And what's important here is that we've actually, in this test, written the first invocation of our API. And let's look a little bit more closely at it. So the one thing that is different here than the rough idea of what we want it to look like is instead of the class object integer representing the type, we're passing a specific object. And we're doing this because we want to keep it simple. We want to add as little sugar as possible at this early stage. But this ends up staying with us for the lifespan of this API. And I actually really, really like how this aspect of it turned out. It might be a little bit more ugly, but it is a lot easier to understand if you are reading the code, especially if you've never seen this before. You can also infer a lot about what behavior this can modify because you can look at the methods that exist on that object. You also know exactly where to look for the rules of the behavior of how integer casting works because you have a specific class that you can look up the documentation for. If you are providing your own types in your system, you have a greppable token. You can find the definition of it much more easily. We also don't have to worry about what are the semantics of dealing with types that Active Record didn't provide. You're giving us an object. It's just Ruby. Ruby just works. And every DSL has a cost. There's cognitive overhead. When you're reading it, you have to then translate that to, wait, what does this actually do? You actually just sort of have to memorize how it works because the DSLs can tend to modify a lot of behavior in a lot of places. And if you don't just know, it's often very hard to look up. Understanding Ruby is no longer enough to understand the semantics of this object now. You have to go look at every DSL that's being invoked anywhere in the class. And there's this really thin line that's very easy to accidentally cross between being helpful and being too magic. And when you're adding new, and yes, I did just justify my DSL by saying don't have DSLs, but this is one of the less DSLEs. I'm more saying as opposed to passing in the class object integer or the symbol integer instead of an actual object. And when you're implementing an API like this, you always want to implement in very small steps. So I had an idea of the rules for what was going to be an acceptable implementation. The main thing was I didn't want everything that this relied upon. I wanted to be or everything that had anything to do with types, specifically what I now call automatic schema inference, where we determine the types of the attributes on the active record model based on the database schema. I wanted that to be implemented in terms of public API. Have this be the single canonical way to represent that API, a typed attribute. That turns out to be a much harder thing to do than you would hope. So for the minimum serviceable implementation, what we can do is we can just modify the columns hash. And this is really, really wrong because we're not modifying the database schema. We're not modifying the columns. An attribute of a model isn't a column. It's an attribute, which is a separate thing. But in 4.1, everything. These two things were tightly intertwined, but it'll do just to really flesh out any problems. But if we just try to modify it directly, we're going to run into another problem here. So this is how columns and columns hash are implemented. Columns returns an array of column objects for those who have never used this method, and columns hash returns those same objects, but instead of being an array, it is a hash where the key is the column name. Specifically in the columns method, which the columns hash method also calls, we are asking the database connection adapter for what it thinks the columns are, and that means that we can't call this from our class macro. It's very important that a class be able to be loaded into memory without a database connection. If it requires a database connection to call that, basically you can no longer deploy to Heroku because when we're precompiling assets, it's in production mode. We're going to eager load all of the classes, and then this tries to get a database connection, but when you're precompiling assets, you don't have that. So we need to make our implementation lazy, and this actually turns out for me to be a thing that pops up more often than not. And so one of the rules that I've decided for designing these APIs is when you do end up having to have a lazy representation, have a strict representation as well and separate the two. Like the fact that we need to define this lazily is an implementation detail, and it's implementation detail of our use case and might not necessarily be the case for everybody, and you might want to force that to be evaluated immediately. So here's roughly what the code for attribute looks like at this point. We're going to convert the name to a string because we need to normalize this. We're going to stick that into a hash. And the key is going to be the name of the attribute, and the value is going to be the type that we passed in. And other important thing to note is that this is designed so that the last one wins, so that we can have a parent class define a type, and a child class inherit from it and also override that type, or the type of that attribute. Then we have the strict version, which I call define attribute. It takes the exact same arguments as attribute. However, it immediately does the actual overriding. It changes the value of the columns instance variable and checks to see if we have one with the same name, and if so, creates a new column object, and that is important. We're not modifying the column object, we're modifying the result of columns to have a new type. And this clear caches calculated from columns means clear everything that's memoized that would have its value changed if the value of columns changed, columns hash being the most important one. And finally, in the method called load schema bang, which is what gets called when we actually need to go and load the schema, we loop over all of the attributes that we had stuck in that hash earlier and call the strict version. So enum became now pretty easy to implement in terms of this new API. We moved all the logic into a type, which I've omitted the body of for brevity, but it is basically a shorter version of all of those blobs that I showed earlier. And we remove all of those blobs. Again, all of these are abbreviated for brevity here. And this is what we replace it with. We are still checking to see if there's a conflict with internal active record methods for all of the names of the methods that we override, because we have infinite private methods that if you wanted to have a method with the same name, you break everything, and that is awful. And then we just call the attributes API. Now, most of our use cases, unfortunately, need to modify the type of an attribute, but not replace it completely. And so what we need are decorators. However, just like replacing the type completely, to get the previous type that we want to decorate, that would require a database connection, and that is bad. So once again, it needs to be lazy. So this is not a public API that I'm about to show, but it is something that I would be perfectly comfortable making a public API, and I think it is just as usable as what qualifies for a public API. And I think this is really important, that every API that you don't expose still be pleasant to use and easy to reason about and easy to understand. So we've got the same thing. We have our decorations, which in this case are going to take a block, and we stick that in a hash. And then once again, in load schema bang, we override, or we call super, and then we loop through this, and we apply each of our decorations. And I won't go into the implementation details of how we actually define these. But so we wanted to have a decorator name so that if you call the same decorator over and over again, this API would be idempotent. If you change just the block that you want to decorate it with, it doesn't decorate over and over and over again. It overrides the original decoration. This is important for things like serialize to also be idempotent. But usually we don't want to come up with like a unique name, and so we end up with a additional API, which I think I have this in the wrong order. Yeah, we have an additional API here where we separate out the column name and the name of the decoration, so that when we have other things that we implement in terms of this, we can basically just pass in like I'm going to decorate this and I'm serialize. So please, the next time somebody calls serialize for the same column, override the original. But if you call a different decoration, those get composed together. And so time zone aware attributes end up like this. Our matcher ends up just calling the predicate that we were calling before, and then we pass through into our decorator API. If that matcher matches, wrap it in the time zone converter type, and the block just gets past the original type. Same thing for serialize. We're just looking for anything with the same name, and if that matches, then wrap it in the serialize type. And this is what serialize looks like in 4.2. If you open up the file in which this is defined, this is it. And I wanted to show you the diff of this file between 4.1 and 4.2, because it's one of my favorite diffs ever. I couldn't get it to fit on a slide, because there was so much code removed that every character was smaller than a pixel. But this is important. We took this specific thing that we were doing and turned it into a generic concept. And both our implementation got much simpler, and we gave the ability elsewhere in the code base to reuse this exact same concept of decorating an existing type. And we can succinctly describe what serialize does in terms of the type API. I'm not going to go over the specifics of this code, but this is what the serialized type looks like. This is the bulk of the logic that actually replaces that giant file that we had before. One of the things to note is, as a side effect of making this possible, we had to fix the whole mutation being detected. So in 4.2, you may have noticed that will change bang is basically useless. It's still there, and it's probably still going to stay around because there might be a reason to call it, but we just now can detect if you modify or mutate an object. So now we've got an actual working implementation of this, and this is actually in Rails 4.2. You could use everything that I have described here in 4.2, although it's only like 80% implemented, so there are certain things like where within a single value would work, but with an array would not work, and other little things. So you shouldn't actually do that, but this is what it looks like in 4.2. The main reason it's not public was because I still wasn't happy with that implementation, where we're overriding columns and columns hash. And specifically, those are public API, so if I do that and I make this public, the side effects of this then also become public. And I would have to go through a deprecation cycle to change it. But what I really wanted to do was make this API universal. This needed to become the canonical way to represent a type, and the place that we end up storing this type information needed to also become the canonical way to get information of how to convert between a value for the given type. And I'm going to then skip the next 8 months of work that went into this, where we made that possible, and that required rewriting a lot of relation and a lot of ARL. But what we ended up with is probably my favorite method from active record internals right now, and that's the implementation of load schema bang. So we're doing the same thing that we were doing before. We go grab the columns hash from the connection, and then we loop over that, and we just call public API. So the type object got removed from the columns, and that was a decision that I made because if I left it there, there are places where you might have access to the connection, but not access to an active record class. And in that case, it's really tempting to grab the type from the column. And other developers on this code base who I might not specifically review that pull request could easily make that mistake if I left it there. So of course it needs to be possible to get a type object from a column object, because this method needs to do that. But it has to jump through several hoops in order to do that, and I've tried to make it so that internally this API screams at you, if you are using a column object for type information, that is wrong. That is not the canonical source of type information. And then we ultimately ended up with several collaborating objects. This one's called attribute. Again, I'm not going to go over the specifics of most of this code here, but this is the object that maintains the actual state and maintains, memoizes the actual coercion, because that can be expensive, and you might want to be able to mutate it later. And then I just noticed that way too many things needed to know that this existed or how to build it, so we introduced attribute set, which is a little bit bigger, but this represents a collection of them, and basically each of these methods ends up being one-to-one with methods that are on active record in the public API, and those all just become one-liners. And then just a quick aside here, because Koichi's in the back there, this method, the first one there, doesn't actually quite look like that. It looks like this, because it's way uglier, because ampersand block has to allocate that proc, and that's really slow, and we should be able to fix it. And it doesn't look like this either, because we fix it on JRuby, and in the end, ampersand block can actually be faster than this form, and this is a huge hotspot in Rails, so it actually looks like this, where we have the pretty code on JRuby and the uglier code on MRI. I linked to a RubyConf keynote where they talk about this specific patch. If you're interested, the slides will be online. So we should fix this. And then in your APIs, in your implementation and in the interface, prefer composition over inheritance. All of the reasons I was mentioning earlier. Greppable tokens are awesome. Have your users pass you objects. Ruby is object-oriented. It's not symbol-oriented. And that's awesome. But objects are great, and we should use them. And specifically, you want to keep your implementation simple. Caveat for reasons that Sam was talking about in his talk yesterday. Those are all not necessarily under this, but if it is hard to understand the implementation of your API, or if there's a lot of branches or a lot of complex interactions, it's probably really hard for your users to understand what your API actually does. And so here's an example of it looking simple doesn't even mean that it is simple. So if a product belongs to user, and I change the name of a product to user, and I call product.save, did the user's name change in the database? Anybody think they know this? Good, because it's a trick question, because it depends on whether or not product is a new record. But you wouldn't even, if you didn't just know, you wouldn't even expect that belongs to changes the behavior of save. And if this is some unexpected thing in your app, where do you even look to figure out what's going wrong? Does save need to know about every possible class macro that can modify it? And that, of course, gems then can also add it. Does a class macro need to state every possible method that could have its behavior changed by it? And if so, that's not a great answer either, because if I'm trying to figure out what is causing save to behave weird, I need to go look at every single class macro I've invoked on the class to figure out which one could modify save. And of course, the answer is all of them, because save is overridden by 20 different modules. And the last piece of designing these APIs is to have a contract and have it be explicit. So here's a couple of things that are true in Rails 4.2 universally that are guaranteed to be true and were not true in 4.1. So the first one is that saving and reloading a model should never change the value of an attribute. Cases where this weren't true were serialized in JSON previously for things like symbol keys being converted to strings. Those are now eagerly converted to strings. One interesting note is that this does mean that we also explicitly do not guarantee that if you assign a value that you get the same object back out. So if you mutate it, you need to get it from the model. Here's another one. Assigning a value to the exact same thing that you got from the reader should never cause the model to be changed. This was surprisingly untrue in Rails 4.1. Serialized, of course, being the obvious case, but there were a lot of others as well. A new model should never be changed. That's pretty straightforward to me here. But same thing, serialized, because serialized assumed it was always changed. This was not true. And then here's the important one for me. Any value that you get from a reader in a model, when passed to where or find by, should return the same model. Anyway, I don't really know how to end this talk. Like, I'm supposed to have some big sweeping conclusion of like the huge succinct point that is quotable and tweetable and whatnot, but I don't have that. So that's the attributes API and the process that went behind it. I hope you like it. Please ask me questions now. Thank you.
I think a lot of people use Virtues to build their own models due to the attributes and typecasting. Have you thought about moving this this group of code to the active model, because a lot of people use active model validations. I don't know if the from database kind of attribute will make sense there, but have you thought about that?
Yes, that is something that is happening right now. We've got a pull request open that I still need to go make a few changes to that does the first half of that. The hard part is that a lot of this has to care about SQL-specific stuff, and I don't want active model to care about the database specifically. So I'm still trying to figure out where stuff like quoting behavior and things like that, which don't make sense in active model should go. Ultimately, this is going to definitely move to active model, and I would actually like to move it to a separate gem so that we can share code between things like Vertus and this.
So once again, thank you to Sean Griffin.